Okay, so in this video, we're going to go over the equation of an ellipse. Before we get into the equation, we're going to take a look at just kind of some background on an ellipse. What makes an ellipse? Right now, here what you see here is, think of two pins, kind of a pin down and then a string between them. Right, the string is kind of loose, and let's say we kind of make it taut, and here we have length 5 on each side, right? As an example. So what we can do here is to create an ellipse, as you see here, that drawing, what you do, the string, then you take a pin and you make the string taut, and you kind of just go around, right? As you notice, as the string kind of goes around, right, you have this oval shape that happens, right? But notice that the lengths of the strings, depending on what point on the ellipse that you are, they vary, right? At first, one of them is longer than the other, right? And vice versa, right? Now, one thing to keep in mind, that even though each individual length on the string changes, the actual total length does not. Right? There's no extra string. We're not removing any kind of string, so that should be right, clear that even though that each individual pieces are changing, the total length is not. All right, so at any point there, the length of those pieces of strings add up to 10 in this case. All right, now we're going to put this ellipse in context of our x and y axes. All right, now those pins are what we're going to call the foci of the ellipse. Right, so let me switch over here to my document cam. Okay, so we have here an ellipse, as best as I could draw one here. And so here, in this ellipse, in our x and y axis, let me go ahead and label here x and y. The equation of the ellipse is this equation that we have here, this x squared plus y squared is equal to 1. X squared over a squared plus y squared over b squared is equal to 1. All right, now where that equation comes from, it's derived from the distance of the length of these strings, right? Which we won't go over the derivation of them, but your book goes over a nice proof essentially of where that equation comes from, right? So if we have these here, it's centered at the origin, right? So we'll have this, we'll call it negative c comma 0, and this one c comma 0. Right? And a point on the ellipse we'll call point xy. Right? So this point has the property that when I square it and divide by a squared, which are constants, right, and b squared, which is another constant, when I square the x coordinate divided by a squared, and then add it to the y coordinate squared divided by b squared, the sum of those is equal to 1. Right? That's how we define a point to be on the ellipse. Right? So these values of c and negative c are on our what we call the major axes here. And so let's go over some points here. Right, so c and negative c, the one along the x, label a0, negative a0, and then this point on the y-axis is 0b, 0, negative b. Okay, so always think of a, b, and c to be positive values. Okay, so then this is called, here, this point here is, or I guess here, let me use a different color here. In this case, for this particular equation, a is greater than b, and when that happens, this is called the major axis. And then this value, or this length here, this one is called the minor axis. Okay, and what we see here is that the length of the major axes is 2a. All right, and we could see the coordinates there, right? The coordinates are a0 and negative a0, right? And the length of the minor axes is 2b. All right, and the coordinates we see are 0b, x being a 0, and 0, negative b. All right, and then the foci are, this isn't clear here, this should be negative c0 and c0. All right, so those are the coordinates of our foci. Right. Okay, now in terms of how A, B, and C are related, they're related in this manner. C squared is equal to A squared minus B squared. Okay, so this is all in the case where A is greater than B. All right, now if A is not greater than, or in other words, if B is greater than A, right, then we have a different situation. Now, what will happen then is the equation will still write as this, right? So let me, as x squared over a squared plus y squared over b squared. Right, but now, here, let me have a new coordinate axis here. So we're going to look at still an ellipse. Right, but in this case, we're looking at the situation where b is greater than a. Right, so now when that happens, we're looking at something that looks like this. Okay, so now notice the difference, right? It's elongated now along the y, right? When the b value is greater than the a value. All right, but the relationships are still going to be the same here. So in the sense where here we, so now instead of this being the minor axis in our previous example, this here now becomes our major axis. Okay. And now this one here, this becomes our minor axis. All right, now the coordinates here, right, these are still, in this case, right, if we do this here, these are still 0, A0, negative A, 0, and then over here we have 0, B, 0, negative B. Okay. All right, and now the foci in this case lie somewhere along the major axis, right? So the foci always lie along the major axis. So here, instead, the coordinates will be 0, C. And then down here, there will be 0, negative C. Okay. And now in this case, the length of the major axis is 2b. and the length of the minor axis is 2a. Okay. All right, and then the coordinates of our foci now are 0, negative c, 0, c. Now the relationship between a, b, and c is slightly different here, so it'll be b squared minus a squared. Okay. All right, so that is our parts of an ellipse. All right, so okay. All right. Okay, now in the case when A is equal to B, whenever that happens, well, you notice we won't have a major or a minor. In that case, we'll just have a circle, right? So that is the special case when A equals to B. Is just the case when we have a circle, right? And there won't be any foci in this case, right? If you notice, these would be equal, right? So that would be 0. We'll just have the center of the circle. Okay, now in both of these cases, we'll look at these equations are when it's centered. Each one of these, the center is at the origin. All right, so we'll take a look at the case when it goes off center.